Alright, welcome back. In this video, I'm going to teach you how to calculate elasticity. Alright, so first we need to figure out what the heck is elasticity. Well, this is used to measure the responsiveness of one variable to changes in another. So essentially this question that we want to ask is, how responsive is the dependent variable to the independent variable? Now, in this context, we're going to be thinking about price and demand. So what we really want to know is, if the price changes, how much is that going to affect the quantity demanded of that good? So in general, there are other types of elasticity. It can be with supply and income and other things like that. But this is where we are right now with elasticity. So here's one that I mentioned, the price elasticity of demand. It's going to be by far the most important one that we're going to do in AP Micro this year. It measures the change in quantity demanded as a result of a price change. So what we want to know is, because remember, the law of demand tells us if the price goes up, we're going to have a decrease in quantity demanded. If the price falls, we'll have an increase in quantity demanded. That's the law of demand. But we want to know how much is that quantity demanded going to change. For some goods, we will see a large decrease in quantity demand from a small price increase. Other goods, though, will see a large price increase and quantity demand won't fall by that much. Elasticity is the determining factor in how much that quantity demanded does change as a result of the price change. The way that we are going to calculate price elasticity of demand, it is equal to the percent change. Delta triangle there is change, the percent change in quantity demanded divided by the percent change in price. Percent change, that is a really important thing to note. It's not the change in the absolute whole number, it's the percent change for each of these. So make sure that you guys have that written down properly. So let's go and practice it. All right, so here you go. Example, when the price increases from $10 to $11, the quantity demanded decreases from 100 units to 80 units. Again, this is what we'd expect according to the law of demand. So how do we calculate this? Well, again, we have our formula. The price elasticity of demand is equal to the percent change in quantity demanded divided by the percent change in P. So we fill in those numbers because first we need to do the percent change. So we got to figure out, all right, how much is quantity demanded percent change? So we went from 100 units to 80 units. So that is 80 minus 100. So our second number minus our first divided by the first. And that gets us to 20 over 100, which is negative 0.2. And then we multiply that by 100, so we get the percent, and we are at negative 20%. That is our change in quantity demanded. Change of price, we do the same thing, 11 minus 10, so second number minus the first, divided by the first, equals 0.1, multiply that by 100, and we have 10%. Now we're ready to plug it into our price elasticity of demand formula, which gives us negative 20% divided by 10%, and our answer then is negative 2. Now, in demand, it will always be a negative number because the change in quantity demanded is decreasing when price increases, and it's increasing when price is decreasing. So we are going to use the absolute value of that number, and we will express our answer as 2. So with demand, we understand that price elasticity of demand is negative. Therefore, we use absolute value, and we will say the final answer is 2. There is an alternative way to calculate the percent change in a variable, and it is called the midpoint method. So instead of doing the typical second value minus the first over the first, what you can do instead is you can find the average or the midpoint of the initial and final values. So I have an example for that on the next one. So again, this is the way that you would calculate it. The percent change in variable x in this case would be the change in x divided by the average value of x, when normally you would do the change in x divided by the original value. So we can see this here. I'm not going to spend a lot of time. You can pause this and look at the numbers if you want. But again, we're looking at the same thing. Price increased 10 to 11, quantity decreased from 80 to 100. Using the midpoint method, we have 80 minus 100, so our change is 20 or negative 20. But then instead of dividing it by 100 like we normally would, because that's your initial number, we're dividing it by 90 because we're doing the average of 180. So 100 plus 80 is 180 divided by 2 is 90. So then we end up with, instead of negative 20% like we did before, we now end up with negative 22.2%. The reason that you would do this is honestly because the AP test might ask you to. Only use the midpoint method if they specifically tell you to do so, otherwise do it the normal way. But the reason it does have some value is because it now doesn't matter which direction you're moving. Whether you're going from 80 units to 100 or from 100 units to 80, you'll get the same answer of 22%. When you use the regular way, it matters which way you go. From 100 to 80 is a 20% decrease. From 80 to 100 is a 25% increase. So that's the advantage to using the midpoint method. Till next time, this has been a LaMoney production.